Thank you. 6 control, 30 seconds. Break. Test lab confirmed tape and TM.
Test lab confirmed tape and TM on.
10 seconds hot run. Stand by for count. 5, 4, 3, 2, 1. Drop it. Drop it.
Man is going to the moon. This is the story of his return. The magic of Project Apollo is man's journey to the moon. The realities have to do with getting him there across the long, deep void of space and bringing him safely home again. Here is George Douglas, Vice President and General Manager of the Ventura Division of Northrop Corporation, where the Apollo Earth Landing System is being produced.
The world will remember for a long time the first manned flight to the moon. The film you have just seen is a record of an aerial drop test, one of many such tests which have been conducted to ensure virtually 100% reliability of the parachute system which will land these men on the Earth when they return from their 500,000-mile journey. We at Northrop Ventura are responsible for the design, manufacture, and test of that landing system. We do everything within our power through our scientific, technical, quality management programs to assure ourselves that our astronauts will be safely returned. To us, the last 5 miles of that flight, the last 5 miles of all space flights, are the most important miles of them all.
Here at the Northrop Ventura facility in Newbury Park, California, is the systems management team that directs and controls the complex design, manufacture, and test operations for the Apollo Earth Landing System. These people have been solving the complexities of spacecraft landing systems since the beginning of manned orbital flight. First, they designed and built the 63-foot ring sail parachute and recovery gear for the one-man Mercury capsule. Then came the scaled-up 84-foot parachute for recovery of NASA's two-man Gemini spacecraft. This management team, therefore, was well qualified to tackle the problems of developing the landing systems for Apollo, as were the engineering design groups. The people and shops where fabrication takes place, and the laboratories where materials are tested to their limits for ultimate quality and reliability. The vehicle to be recovered is the 3-man Apollo Command Module, weighing more than 5 compact automobiles. The Earth landing system began as a mental concept formed around stringent requirements. It must function under all conditions within the atmosphere to slow the vehicle from more than 400 miles an hour to 25 feet per second. The device must be of low weight and occupy little space. From the concept evolved a system of 8 parachutes to be deployed in order by an electronic sequencer. First at 25,000 feet, two 13-foot drogue parachutes would be fired from their mortar containers to stabilize the descending command module. At 10,000 feet, the drogues would disconnect and three 7-foot pilot parachutes would be mortar deployed. Their function, to pull out the three main 83-foot landing parachutes. The three main parachutes would operate first in reefed condition to prevent opening shock. Then, after 8 seconds, fully open by action of automatic reefing line cutters. A cluster of three ring sail parachutes was chosen as the main decelerator. Two are sufficient for the Apollo landing, the third providing a margin of safety. Designers began detailed layouts of the major sub-assemblies and established specifications. Special companies throughout the nation were selected to provide parts and materials. Nylon suspension lines were braided on the West Coast. Steel-strong nylon straps came from the Midwest. Tapes and webbing came off the lines in Pennsylvania. High-strength, low-weight nylon for the main parachutes on the East Coast. A Southern California firm produced the reefing line cutters. No larger than a pencil, this device must ensure that all three main parachutes open at the same precise second. As various components began arriving at Northrop Ventura, the drogue and pilot parachute mortar cans are assembled. The Northrop design sequence controller begins its cycle of careful hand production. Each unit contains a logic circuit composed of baro switches, time delays, switching devices, and circuits to fire pyrotechnic charges. Here, circuits and components are laid out and welded with inspection at each step. When all components are assembled in proper position, the entire package is carefully fitted into a steel mold. Then, under vacuum, it is encapsulated in special plastic to ensure that no part may malfunction or be shaken loose by severe vibration. The encapsulation, or potting, takes place in this special chamber. The sequence controller finally emerges as a solid block approximately the size of a cigar box. At final checkout, this small electronic brain, which senses all normal or emergency conditions under which it should begin operating, is so reliable that there is a probability of only one failure in 10 million spacecraft landings. To double that safety factor, 2 sequence controllers are included in each landing system. In the Paradynamics laboratory, bolts of nylon weighing less than an ounce to the square yard are rolled out on tables in preparation for cutting. Woven to a special waffle pattern, this grade of nylon offers the highest strength with lowest possible weight. For each main parachute canopy, more than 800 square yards of nylon are formed into 816 individual sails. Skilled seamstresses sew more than 2 miles of tape and webbing to combine the individual sails into each canopy. So high are the quality standards that each spool of thread is identified as to date, fabrication, and specifications. Each main parachute contains more than 3.5 miles of thread, 2 million individual stitches without error. Finally, every inch of the completed parachute is inspected for flaws, including, for example, the pocket which contains the reefing line cutter. Completed sails are checked over a light table. By time-honored custom and necessity, the parachute is packed into its high-strength nylon container under the guidance of one man's hands. Each fold is carefully arranged and pressed into place. Nylon enough to cover an average backyard must fit into a space no larger than a bushel basket. A man's strength is not enough. This specially designed hydraulic ram compresses the parachute folds while a vacuum pump exhausts residual air from the bag. At the end of the more than 2-day operation, each main parachute pack has the density of a block of maple. Each pack in a plastic wrapping is inspected by a quality control expert. In the meantime, sample packs have undergone extensive qualification testing under centrifugal force. High vacuum simulating conditions to be encountered in outer space. And high temperature, equal to that generated when the space vehicle re-enters the Earth's atmosphere. Equally intense is the environmental and qualification test program for the drogue and pilot parachutes and their mortars. Here a drogue mortar system is being prepared for an actual firing on the Northrop Ventura test range. Technicians establish heat conditioning to simulate a re-entry environment. More than 400 such firings have been conducted during development and qualification of the Apollo Earth Landing System. Computer analysis is applied at a level never before attempted in parachute technology. Every possible failure point is identified and corrected before a man's life must depend upon the system. At the Defense Department parachute facility near El Centro, California, individual parachutes are test dropped from high altitude. Then, 2 parachutes leading toward full system tests. Finally, all major components are brought together here on the parachute deck of the Apollo boilerplate command module. First, the sequence controller, heart of the system. The 2 large, round drogue mortar cylinders. The main parachutes in their heat-resistant white fabric packages. The small mortar containers for the pilot parachutes, which pull the main parachutes from the protective covering. Time after time, the entire system is tested in airdrops from a C-133 aircraft specially modified for this task. And finally, the most severe test of all. Here at the White Sands Missile Range in New Mexico, the Apollo command module is mounted upon a Little Joe 2 rocket booster.
3, 2, 1, 0.